This lesson will cover the basic concepts of algebra. Topics will include the language of algebra, fundamental properties, and evaluating algebraic expressions. In algebra, letters are used to represent numbers or sets of numbers. Some commonly used letters are A, B, M, N, X, and Y. Even though we can choose any letter, these are the most commonly used. Usually, we try to select a letter that is easily recognizable for the quantity. For example, we use the letter M when dealing with motion and the letter T when dealing with time. The letters used to represent a number are called variables. Variables represent an unknown quantity, which implies it can take on different numerical values. For example, in the expression x plus y, we can replace x and y with any quantity. Replacing x with 2 and y with 10 yields 2 plus 10 equals 12. Algebraic expressions may contain constants, as well as variables. A constant is a fixed numerical value that will always remain the same. Consider the expression x plus 6. The variable is x and 6 is the constant. No matter what numerical value we use for x, we will always be adding 6. In the expression 10 plus y, the number 10 is the constant and y is the variable. We can replace y with any number and still be adding it to 10. The symbols used to operate on variables in algebra are the same as the ones used in arithmetic, except for multiplication. The sum, difference, and quotient of two numbers are still expressed the same way. We can use the fractional form m over n to express a quotient, or just use the division symbol. When it comes to multiplication, all these forms you see here means 2 times y. Avoid using arithmetic multiplication symbol in the example 2 times y because it can be confused with the variable x. The method most commonly used is the last one. Only use this method when expressing a product involving variables. 2 times 5 cannot be written this way because since this is the numeral for the number 25. An algebraic expression is a mathematical structure consisting of variables and constants, which are combined by addition, subtraction, multiplication, or division. These 6 examples are algebraic expressions. Notice there is no equality or inequality sign between any of these expressions. Algebraic expressions do not use equality or inequality symbols, as that would make it an algebraic equation. Algebraic equations will be addressed later. Algebraic expressions are made up of terms. Terms are individual quantities separated by the signs of addition and subtraction. For example, look at the table of expressions. The expression 4x, or 4 times x, only consists of a single term, which is 4x. The expression 6x plus y plus 2 consists of 3 terms, 6x, y, and 2. The expression xy plus 6 times a minus b plus 2 consists of 3 terms, xy, 6 times a minus b, and 2. Notice that 6 times a minus b is one term, not 2, because the 6 is being multiplied by the difference of a and b. It is only a term if it is connected with an addition sign or a subtraction sign. The expression m plus 3 divided by 6 plus 2x minus 2 only has 2 terms, m plus 3 divided by 6 and 2x minus 2. The last example has 2 terms, x squared and negative 8 times b, or negative 8b. Notice we include the minus sign as part of the second term. A term includes the sign that is immediately before it. It is important to understand the difference between terms and factors. Terms are the individual quantities of an expression separated by addition or subtraction signs. Factors represent products and denote multiplication. For example, observe the expression 6x plus y plus 2. It consists of 3 terms, 6x, y, and 2. The first term, 6x, represents a product of 6 times x, which has the factors 6 and x. If a term consists of a product involving numerical and variable factors, then we refer to the numerical factors as numerical coefficients or just coefficients. If a term consists of only variable factors, such as this one, then the term's coefficient is understood to be 1. In the expression 6x plus y plus 2, the coefficient of the first term is 6, the second term's coefficient is 1, and the last term is a constant. When working with algebraic expressions or equations, we replace the variables with specific numbers. The numbers we use to replace these variables are from various sets of numbers. Here are the 6 sets of numbers we could use. Natural numbers are the counting numbers such as 1, 2, 3, 4, and so on. Whole numbers consist of the set of natural numbers in addition to the number 0. Integers are the negative numbers, 0, and positive natural numbers, as shown here. Rational numbers are fractions of the form p over q, where both p and q are integers and q cannot equal 0. You may never have 0 in the denominator. Irrational numbers are any numbers that are not rational. Irrational numbers can be written as a decimal but not a fraction. 2 examples of irrational numbers are pi and the square root of 2. They both have endless digits to the right of the decimal point. The last set is real numbers. Real numbers consist of the set of irrational and rational numbers. The laws and properties we learned in arithmetic apply in algebra as well. The properties of addition with real numbers are the commutative and associative property. The commutative property states that if a and b represent 2 real numbers, then a plus b equals b plus a. So 2 plus 3 is the same as 3 plus 2. They both equal 5. The associative property states that if a, b, and c represent real numbers, then the sum of a plus b plus c also equals a plus the sum of b plus c. In our example, we see that 6 plus 3 plus 2 equals 6 plus 3 plus 2. When we solve the problem, we get 9 plus 2 equals 6 plus 5, and both sides of the equation equal 11. Here we have the same properties just with multiplication. The commutative property of multiplication states that if a and b represent 2 real numbers, it is not affected by the order in which you multiply them. So a times b equals b times a. The associative property of multiplication states that if a, b, and c are real numbers, the multiplication in which they are grouped does not affect the result. The product of a times b, then multiplied by c, equals a times the product of b and c. In the example, we see the product of 3 times 4, then multiplied by 5, also equals 3 times the product of 4 times 5. Both equal 60. The distributive property states that if a, b, and c represent any 3 real numbers, then a times the sum of b plus c also equals a times b plus a times c. Multiplication is distributive with respect to addition. For example, 2 times 3 plus 4 will equal 2 times 3 plus 2 times 4. Both equal 14. The inverse property of addition states that if a is any real number, then a plus negative a equals 0. Every real number a has a unique opposite real number negative a, so that when a is added to its opposite, the sum is 0. The opposite of a number is called the additive inverse. For example, 5 plus negative 5 equals 0. Addition and subtraction are considered inverse operations because subtraction will undo addition and addition will undo a subtraction. In this example, 8 plus 3 equals 11, and 11 minus 3 equals 8, or 11 minus 8 equals 3. The inverse property of multiplication works this way too. The inverse of multiplication states that if A is any non-zero real number, then A has a unique opposite real number 1 over A, so that when they are multiplied, the product is 1. So 8 times 1 divided by or over 8 equals 1. This is called the multiplicative inverse. Multiplication and division are considered inverse operations because division will undo multiplication and multiplication will undo division. In this example, we can see that 8 times 3 equals 24. So 24 divided by 3 equals 8, and 24 divided by 8 equals 3. The identity property of addition states that if A is any real number, that A plus 0 equals A. There is a unique 0 such that any real number added to it yields itself. 0 is the identity element of addition. For example, 7 plus 0 equals 7. The identity property of multiplication states that if A is any real number, then A times 1 equals A. So any real number multiplied by 1 yields the number itself. For example, 4 times 1 equals 4. We discussed earlier that an algebraic expression represents an unknown quantity until the variable is replaced with a specific number. When evaluating expressions, remember to use parentheses when replacing the variable with the indicated value. Also remember the order of operations when evaluating the expression. It is important to follow the rules and order of operations for adding, subtracting, multiplying, and dividing. Here we will evaluate an algebraic expression while remembering our order of operations. In this example, we have 6x plus 5, where x equals 2. Notice how we substitute the variable x in the expression with 2 and use parentheses to indicate the correct operation we will be performing. By doing this, we get 6 times 2 plus 5, which then by the order of operations, we get 12 plus 5 equals 17. If we didn't use the parentheses, it would be 62 plus 5, which would give a completely different answer.